Hello guys and welcome back to my YouTube channel. Today we will be discussing a few things, so let's dive in. So first, remote access allows you to actually connect to a device without physically being near it. You could be, like it says here, this is a computer switch router in Seattle, Washington. Reverse, this is the switch in Tokyo, Japan, and you can be in Seattle, Washington. Remote access allows you to connect to it remotely without having to be physically near it. Right? And there's two forms of remote access. The first one is Telenet. It operates on TCP port 23. It allows you to remotely connect to a device without having to be physically near. The only thing downside about it is that it lacks encryption. So everything that's sent, if you use Wireshark, you can actually go into the packet that it captures and see that it's in plain text. Plain text just means like this, human readable. So it'd be transmitted using plain text. So if you send the word Telenet, it'll actually show up as Telenet if you use Wireshark to capture it, right? So it's not that very secure. It's ideal for isolated and trusted networks with minimal security concerns, right? And the VTY lines. So they are logical interfaces on a device that users can use to connect to via SSH or Telenet. And they enable administrators to configure and manage devices via the CLI remotely. It can support simultaneous remote sessions. For example, I think you can get like 16 active VTY line connections or remote connections to routers and switches, if I'm not mistaken, right? And then you can also use security like ACLs to allow only specific users to actually get in, as well as encrypt the password and use SSH for encryption. We'll get into SSH in a bit and how to configure Telenet. First, you access the VTY line with line VTY, followed by the number of lines that you want to get. So here it'd be 0 through 4, so 5 VTY lines you're going to configure. You set the authentication using the password followed by the password that you want to make, and it's going to prompt you for it when you try to connect to it via Telenet. And then you also have to assign an IP address to the actual device, because you'll use the IP address on end host like a laptop, desktop, to actually connect to the device that has the IP address. All right, and then this can be used. Let's actually let me remove this, and then let's see. Let's do a PC. Let's do a router. Then fast forward. Do this. So first, until then, it's not really used anymore. So let's just set this up and we'll configure SSH on it later. And conf t, and then let's just add an IP address, and then we'll save the configurations for SSH since it's more secure and used in the industry more than Telenet since it's more secure. Right. Interface IP add line 2.16.8.10.1. Just give it a /24, no shut. And then let me just copy this. And right, perfect. For now, this should be enough. Actually, let's give this a second available IP address. All right, now let's go back into this. So this is how to set it. For Telenet, you need to define the host name, then the domain name, create a local user using username followed by the user, and then the password. It could be a regular plain text password if you just put password, or secret. It could be, and then if you use secret, it actually configures it or writes the password in the running config using MD5 hash. So that's just the added layer of security if you want to put secret here instead of password. And then here you go into the line VTY 0 through 4. And then you can put in login local since you configured this, which would be the local database on the device. And then you specify transport input Telenet, which only allows access via Telenet, right? And that's pretty much it. I mean, we can do it just to show you. So here, exit, host name, R1, IP domain, name. We'll put example com, and then we'll do username. We'll put my name, Edwin, and then secret for extra encryption, MD5 hash, and then we'll put Cisco in all capital, and then we'll do line VTY 0 through 4, login local, and then transport input Telenet, right? And then that should be enough. So now let's try to connect to it using Telenet 68.10.1. Username Edwin, and then here, even if you type everything as it is, it's not going to show. It's hidden. So right now we're in the CLI. Let's do the enable password. Forgot to do that. Enable secret, and then we'll do CCNA, right? Let's go here. If we type in enable and then CCNA, now we're in the configure in the, so we did the enable, typed in the password, which was CCNA, and now this is us being in privilege exec, and then I put conf t. Now we're in global configure. Now we're in the CLI, show run, or do show run, just to show you. And see, this is the enable secret that we put the CCNA. 5 means it's enabled in MD5 hash. The username Edwin, and then this is CCNA. No, Cisco capitalized. Again, MD5 hash, the domain, and then the host name here. And yeah, that's pretty much about it. Did login local to use the local database on the device, transport input Telenet, and that's about it. So now we can just do exit again, and it terminates the session, right? So now let's just do show run. Let me just copy this and then exit, reload, and then we will continue with the lecture. All right, now the good part, SSH. So SSH is a remote access protocol that also implements encryption. So if you use Wireshark to actually inspect the traffic that's being sent and it's using SSH, it will be like earlier, how it had the MD5 hash. Let me see if I'm still able to actually pull it up. Yes, so it's going to be something like this, right? If you try to use Wireshark to actually intercept the traffic, it's going to be encrypted, something that's not human readable, right? And it uses TCP port 22 and supports authentication, right? Remote login, file transfer, tunneling, automation, right? It uses TCP port. It uses public key cryptography for authentication, supports password-based and key-based login, and data is encrypted end-to-end during the session. Right, said that. 22, more secure. Yeah, Telenet is outdated. So now let's actually go ahead and configure it. So let's go into here, and I'll actually go about the process. First, let me just type it in, conf t, and add the IP address first. Paste it here, exit. Let me go back and put no shut. All right, so to define or to actually implement SSH, you have to define the host name. So host name first. Let's do the same one, R1. IP domain name, the domain as well. Example.com. And then this is the step that was Telenet didn't have. So it's crypto key, generate RSA, and then you can do the generate RSA, and then it should give you the and then yeah, okay. I was missing it. So you can actually extend it there, but for now we'll just crypto key generate RSA to generate the keys, and you can do as many bytes. Let me show you how much. Oh, it says it here from 36 or 360 to 4096. For now, we'll just do. Let me actually do that again. So 1024, and it's gonna replace them. Yes. 1024. Perfect. It says there generated will be non-exportable. Okay. So now if we do show run, the key should be there. Here. And enable. Let me see if I'm able to actually find it here. Since it's enabled, let's see if show exit, show IP SSH. Show SSH. All right. So the keys have been generated. So now let's go into the BTY lines. So conf t line VTY. Let's do 0 to 15, and then we will do password. We'll do Cisco, and then login. We'll do transport input SSH to allow only SSH, and then that should be enough. Do show run, and let me show you here. All right, so here, so password is Cisco, login, and it's only allowing SSH. So now let's try to configure it now. Let's do copy, go into here, go into command prompts. So let's do SSH, I think it's L at, I think it's, should be at, and then followed by, say, I think I actually have to configure the username. So username, actually let's remove the login here and use login local for the local database. So let's go into not line console, it's line VTY 0 through 15, no password Cisco, no login, and then let's actually create the local login first. Username, Edwin, secret, Cisco, line, VTY, 0 through 15, login, local, do show run just to see. Perfect, now it's going to use Cisco here. All right, now it should be SSH -L, the name or username, and then the actual IP address that we're trying to connect to. Give me 1 second while I find out the syntax of the command. Okay, I'll be right back. All right, I'm back, and let me just show you how to do it correctly. So let's go to this. So it's just SSH and then the username followed by the IP address that you want to connect to. And I'm pretty sure it's 10.1 if I'm not mistaken. Password should be Cisco enable. Let's put that actually again. I forgot to do that. Enable secret CCNA. Let's run that again. Then conf who shall run. Right. And that's pretty much it. Let's actually try to disable. Like if we disable it, the connection will terminate. So just to show you, interface, because we are, see it's shut down and we're no longer able to see the connection time now. So if you actually shut down the physical IP address that you're or the physical interface of the IP address that you're using to connect to it, it will terminate the session, right? But yeah, that's pretty much all for SSH. All you really need is the domain name, excuse me, the host name first, then the domain name, then crypto key generate RSA. Then you go into line VTY line configuration mode using line VTY followed by the number, the lowest end to the highest end, and then transport input SSH. And that's about it for configuring SSH. So let's go back to the slides here. And here we're going to learn about NAT, or network address translation, right? And what NAT is, it allows private IP addresses from an internal network to actually communicate with the public network using a public IP. It allows multiple devices on a local network to share a single public address. There's actually multiple versions of NAT, and we'll actually dive into that later, right? It provides IP address conversion and simplifies network internet access. It also masks private IP addresses, enhancing network security. Right, and this is basically a private IP address. It's going to use a public IP address like this one here to actually communicate with the network. So it's one-to-one. This is also hidden as well, so it's not revealing any of the internal network to the public internet, which is a scary place, right? So benefits of NAT. It reduces the demand of IPv4 addresses, conserving public IP addresses. It adds a layer of security by hiding internal network traffic and details, and it simplifies network management for devices accessing the internet. Okay. And there's types of NAT. So static NAT is one-to-one, which really doesn't like help with public IP address conservation, as it's just one-to-one. It's like using just a public IP address for each device, which isn't really helping conserve any addresses. And it's permanent as well, by the way. So it's static NAT is permanent. Dynamic NAT is pretty much the same thing as public NAT, but it temporarily maps a public IP address to a private IP address, right? And for example, let's say you have a pool of 10 public IP addresses. If there's 10 devices actively using that public IP, all 10 of those public IP addresses, the traffic will just be dropped from the private. Like it'll have to wait its turn for it to actually use the dynamic or the public IP address if you're configuring dynamic NAT, which isn't really in use today since it's not really helpful in conserving public IP addresses. But PAT is what's mainly used now in the industry, right? And what PAT is, it maps one public IP address to many internal private IP address. And I think you can have 65,535 addresses or internal users using one public IP address. And it's really good. And it keeps track of the connections. For example, let's say there's two hosts. It differentiates the traffic using the public IP address using ports, and we'll actually get into that later in these slides, right? But look, as it says, PAT is the most common NAT type for home and businesses. It's like when you pay for your ISP, like AT&T, Comcast, things like that, you're basically paying for the public IP address usage of it, right? And as it says, NAT use cases, home routers enabling internet access for multiple devices, businesses managing shared internet connections, right? Again, so static NAT is using this IP NAT inside source static, and then the private IP address, you map it to the public one, which isn't really good. You also have to first go into interface configuration mode and actually define this as the IP NAT inside, the internal interface of NAT, and this is the pub as the outside interface of NAT, right? Okay, so and then NAT address types. Inside local is the private address assigned to a device from inside the network. So it's from the router's perspective. It's the IP address of the internal network from the inside of the internal network. Public IP address inside global is the public IP address representing the internal device to the outside world. So it would be this one right here. This is what the world sees as this, right? Outside local, the IP address of an external device as it appears to the internal network. So it would be like it could be 200.10.13.5. That would be the what this is saying as the outside local, right? And then dynamic NAT. So you set a pool of IP addresses that your public IP addresses that you're allowing your internal devices to actually use, and it requires an ACL to control which traffic can actually be translated. Even if it doesn't get translated, it doesn't deny it. It just doesn't get translated, right? So for example, you make an access list right here from to allow traffic from 192.168.1/24 to get translated. Let's say 192.168.3 comes and tries to use the access list. It won't get dropped or denied or anything. It just won't get translated to use the public IP address. That's about it though, right? And requires ACLs, which internal addresses are eligible for translation. Uses a defined NAT pool, which public IPs are dynamically assigned, and they're temporarily assigned. They're not permanent like static is, right? And it supports one-to-one address mapping. Each internal device needs a free public IP address to access the external networks, right? And if they're all being used, then the traffic will be dropped, and I'll have to wait its turn until one of them becomes available again, okay? And this is mainly what we use in the industry today now, right? So port address translation, or PAT overload, or NAT overload, excuse me, is a type of NAT that maps multiple private IP addresses to a single public IP address. It differentiates connections using unique source port numbers. Remember how I said it earlier, multiple devices, up to 65,000 are able to use it, and it keeps track of those connections using ports, commonly used in home businesses to share one public IP address. Operates on layer 4, tracking traffic via TCP and UDP ports. So this is all of the internal devices are able to use this one public IP address here to actually access the internet, right? And how PAT works. Private devices use unique source ports for connections. The router translates private IP addresses and ports to the public IP and unique port. It tracks sessions using a NAT address translation table. Ensures traffic returns correctly to the ensures return traffic is correctly routed to the initiating private device. So this one really steps towards, or actually, what's the correct wordage? Like assists with IP address conservation. Like it's one-to-many instead of permanent one-to-one or temporary one-to-one mapping of public to private IP addresses, right? So it allows multiple devices to share a single public IP address. It reduces the need to purchase multiple public IP addresses, and it supports large networks with many devices, simplifying internet access and internal networks. So this is it. Let's actually configure this on packet tracer. So we'll leave this here. Let's do G00, no shut, exit, and now we'll put this here. We'll just add a few more devices just to make it easier for you to understand and see how PAT actually works. We'll do this. Hmm. I guess not. All right, we'll remove this for now and just have two. And let's see. Let's configure another router here. Connect this to this. Give me 1 second actually while I see what's actually going on. I'll be right back, okay? Alright, I figured out what was going wrong. And basically we needed an expansion slot or a NIC, network interface card. So we added this right here, NIM2C, and it looks like this. You just have to power it off first so you can actually add it. It's powered on. So now I added it to this one as well. Just making sure is it on? No, turn it on. All right, perfect. While that loads, we'll make sure this one's on as well. All right, this one's on, and then we'll use a serial connection. All right. And here we will put just a color right here, and then we'll put this as a 0. We'll put this /24, and then we'll label this as 0.1. This is 0.2. This is 0.3. And then here we will put a point-to-point public IP address. Oh, and we'll do a /30. Right? So let's get rid of this, that, and then let's actually configure these devices. This is 1, and this is 2. 0.2. This is 1, and then this is 2. All right. Let's just configure these devices with the appropriate configs. 10.2. Oh, excuse me, 10.1. I think it's 2.168. 10.2/24. Put this as 3. Let's actually configure with it as well. 10.2. So this is gonna have duplicate. We'll have to change this to, let's just say 5 for now. All right. So this one is 2, set up as 5. So this should be, just put this as 3.3. So 1, 2, 3. This one's 5. So there should be a switch here, and let's actually configure that. Let me get rid of these connections really quick. Whoops, no. Move this. Sorry about that. Let me just quickly add a switch to aggregate this. Boom. Do that here. Here. Now this one's 1. We'll remove. This is 2. 3. Remove this. Alright, perfect. So let's change these configurations just one last time. That's good. This one's 3. And then let's just confirm it really quick. 2, 1, 3, 1. All right. Now let's do the configurations here. Do no and conf t interface G0/0 IP at 192.168.10.1. Oops, forgot the subnet mask. No shut. Exit. Actually, let's go back into that interface and do IP NAT inside, and then let's go into serial interface serial 1. Perfect. IP add 203.0.113.1, and then we'll give it a /30. Just move this to the side so you can see better. We'll do no shut, and then IP NAT outside. Remember, for NAT, you'll always have to define the inside local, which is this interface facing the internal network, and the outside facing the public internet. We'll just change this to internet here. Let's go ahead and configure this one really quick. No. Enable conf t hostname internet interface, same thing. So 3.0.113.2, and then the subnet mask is a /30. No shut. Exit, and then let's just add a loopback interface to simulate the actual internet. So interface 8.8.8.8, or no, interface loopback 0, IP add 8.8.8, exit, and then to advertise it, we'll just do OSPF, right? OSPF 1, network 203.0.113.0, and we'll just use a /30, area 0, and then we'll also advertise its loopback interface, which simulates the internet, right? Exit. Do the same thing here. Exit, router, OSPF 1, network. Do the same thing here. Advertise its public interface or outside interface, the one with the public IP address. O /30, area 0, and then network will advertise the 2.168.10.0, 0.0.0.255. Remember, it uses a wildcard mask, so only the zeros have to match, right? And as you can see, it already has OSPF adjacency, right? And then do show IP route just to show you. And it learned its address to get here. It sends it to this one right here. All right. So we also just configured OSPF for just easier use, right? But now let's configure IP NAT or NAT overload, excuse me. So we'll do IP NAT inside source. Well, let me do the access list first. access list 1 permit 192.168.10.0, then wildcard mask. Again, it uses only the zeros have to match, so any traffic that has this 192.168.10 will be translated, right? The last octet, the 255, can be changing, so it allows both of these to actually be translated to this public IP address here, okay? To that, and then IP NAT inside source list, and then 1, because this is access list 1 right here. We'll do interface, and then we'll have to specify the interface, and then we'll do overload. Overload is the command that specifies pat or NAT overload, right? That's basically it, right? So we'll do this overload, and that's pretty much it. Let me just show you the running config. Right, so that's the OSPF we configured to allow it to ping this loopback interface. Let me add that here. 8. Right, and access list allows traffic from 192.168.10.0/24 network, everything here to be translated, right? So, and then IPNet inside source list 1, perfect. So let's go ahead and actually ping. Let's go here, ping 8, 8.8.8.8.8. Copy that, that, paste. Do it a few times actually, just to show you the table as well. Exit, show IP NAT translation, and see here the global IP address and then the ports that it's using. So you can see pat based on the ports right here. After the comma is the port that it's using, and then these are the addresses that it's translating: 3, 2, and then the protocol as well, ICMP, and then destination, right? And it uses ports to keep track of the actual connections to the appropriate end device, right? Let's see, I'm pretty sure that's it for today. Yep. Thank you for tuning in, and have a good one.